picking up where we left off, we have just figured out how to learn what the limiting reactant is in a given reaction. Now we're going to figure out how much of the excess reactant remains after reaction is complete. So in this example up here, we had magnesium left over, right? We've identified that HCl was our limiting reactant, which means magnesium is going to be left over. So the question we're going to try and answer now is how much magnesium remains after the reaction is complete, okay? So again, remember, we're going to use up all of this HCl, and the reaction is going to stop because we're going to run out of one ingredient, which means some magnesium is left over. So when it comes to finding excess, we are going to walk through how to find how much excess magnesium remains in this problem above. However, there's a few steps. So the first step of 3 is to start with a given amount of the limiting reactant. People always make the mistake and they start with the excess, but no, you should start with your limiting reactant and always start with the given amount that you were given. So our problem right now, when we're about to solve this problem, we're going to start with the 6 grams of the HCl. Then we're going to use the ratio between the reactants themselves. Again, we're not solving for products right now. We're solving for the how much of the excess we used to react with the limiting to find our answer. Okay, so that's what we're going to do next, is we're going to use the ratio between reactants to figure out how much of the excess was used, keyword used, okay? And then our last step is to subtract what was used of the excess from what was given of the excess, and that's going to find us our extra amount. Okay, so let's go ahead and crunch this out. I'm going to move my little hover cam a little bit so we can see a little bit better. All right, here we go. So step 1, start with the given amount of the limiting reactant. So in this case, we're going to again start with the HCl because the HCl was the limiting reactant in that problem above. And in the problem above, we were given 6 grams of that limiting reactant. So that's what we're going to start with. We're going to say, okay, 6 grams of HCl. The question we want to answer for ourselves is how much of this HCl reacted with the magnesium. I'm sorry, I should say it the other way around. How much of the magnesium reacted with the HCl? So we're going to be using the ratio between these two things in our balance equation. So taking a look, it's a 2-to-1 ratio. But before we can use the ratio, we have to get into moles. So using our molar mass, 1 mole of HCl is 36.46 grams. Again, now we're going to use the ratio between the two reactants. So this is a 2-to-1 ratio. So we're solving for the magnesium, so 1 mole of magnesium and 2 moles of HCl. And then finally we want to get that into mass, so 1 mole of magnesium weighs 24.30 grams. And we'll get an answer, 2.00 grams of Mg. Okay, so again, it's not enough to understand, or not enough to just crunch the numbers. You have to understand why we're doing this, right? So this ratio is basically saying, okay, if I start with this many grams of HCl, how much of magnesium am I going to use? And we know that for every 2 moles of HCl that we started with, we're going to use 1 mole of Mg, and that's why we can use this ratio to help ourselves solve this question. It's like having like 2 pieces of bread for every 1 hot dog, right? It's that 2-to-1 ratio. So if you have 6 pieces of bread, how many hot dogs can you make, so on and so forth. Okay, so anyway, there you go. So in this case, our question gives us how much of the magnesium was used. This is so important, and if you're going to make a mistake, this is the mistake you're going to make. You'll stop here, okay? So many people say, oh, this is the answer to my problem, so 2 milligrams or 2 grams of magnesium are left over, and no, that's not the last step. That was only step 2. That told us how much magnesium reacted with our limiting reactant, okay? So now that we know how much magnesium reacted, we can figure out how much remains by doing some subtraction, okay? So we started with 5 grams of magnesium, and so we used 2 grams, so it's a very easy math problem, but I'll put it on the paper anyway. 5 grams of magnesium, or what we were given, okay? And then we subtract the 2 grams of magnesium that were used, keyword used, right? And that gives us our 3 grams of magnesium remaining. And that is our final answer. Okay, so like I said, If you're going to go wrong, it's that you forget that this is actually the math that was used instead of remaining. So make sure you're doing this last step, and make sure you're using the ratio between the two the two reactants in order to do the problem. Okay, so now that you've seen one example, I'm going to have you guys do the next example. So I want you guys to look back at problem number 1 at the very beginning of our notes, right? This guy up here. Okay, and I want you guys to figure out how much of the excess reactant remains. So in this case, you're going to be solving for the NH3. Okay, so go ahead and pause your video, do the math. Starting with this, tell me how much of the excess NH3 remains after the reaction is done. All right, let's see how you guys did. So step 1, you guys should have started with the given amount of your limiting reactant, which in this case was the 90.4 grams of CuO. The next thing that you're going to want to do is turn that into moles. So 1 mole of CuO weighs 79.55 grams. Now again, we want to use the ratio between the two reactants. So if you look back at that balanced equation, it was 3 moles of copper oxide for every 2 moles of NH3. Again, because we're trying to figure out how much of the NH3 was used when this reaction occurred. And again, that's gonna get us into, let's say we want grams. So 17.03 grams. All right, crunching this out, we're gonna get 12.9 grams of NH3 was used. Key word, used. Okay, so now that we know how much was used, we're just going to subtract from the given. So in that problem, if you look back at number 1, it tells us that we were given 18.1 grams of NH3 to start with, and we subtract what we used of the NH3, and this means after the reaction stops, okay, so we've got our given minus our used. So after the reaction stops, we're going to have 5.2 grams of NH3 still hanging around in our reaction vessel because it did not react with the limiting reactant. Okay, so that is how you find excess reactants.